Okay, so welcome to your third session. It feels like we've been here forever and ever, but it's only our third session. I know that we are way behind as compared to what you need to submit for your assignments. But that does not stop you from asking for help if you are stuck anywhere, you don't know how to answer any questions in your assignment. The reason being, these sessions are also meant for preparing you to write the exam, not per se to submit the assignment, but to write the exam, which is the most important assessment that will determine whether you can move forward, who you can graduate, or for those who are doing STA1610, you can graduate because this is closer to where you would have been, and some of you move to the next type of a module. So I have been sending you emails on the WhatsApp group for those who are on the WhatsApp group to say, if you have any issue, any query, any challenge, any problem, do not hesitate to contact me, or to even post on the WhatsApp group to say, I'm having a challenge with question number this, and you put a screenshot of that question. You must remember as well, on this platform, on the online environment here, I have 3 modules that I'm assisting you with. So it means sometimes I might not even have the opportunity to get some of the typical questions that you have from your assignments or from your module to do online. But you have that opportunity outside of this platform on MyUnisa, on the WhatsApp group, to engage with me. I also send you the other communication strategy. For example, like you can communicate with me or set up a one-on-one session with me by sending an email to my email address, or also to this email address, the UNISA email address, because they also need to keep record of how many students are requesting for the services. In order for us to continue helping you, it means we need to be sure that UNISA students do really want the services, because we cannot have the services and UNISA students are not taking them up. Then we are wasting our time and we could be doing something else or waiting for you to respond, whereas we could be doing or assisting other students from other modules or other content. So all this, everything that we do at UNISA, it's free of charge. No charge, no payment, nothing, mahala. This is to help you make sure that you succeed at the end of the day. So take up the opportunity and seize the moment. It is meant for you, to support you. And with that, we can start with this week's session. I have posted the attendance register on the chat. Please make sure that before you leave the session, you sign up. You put up your student number there. You sign up onto the register. And at the end of the session, please do not leave before I post the feedback form. It's also very important because we also want to know the quality of the work that we do and also the quality of the systems that we are using. So please make sure that you complete that feedback form at the end of the session. So let's start with today's session. Today, we're going to be looking at quartiles. We're going to be looking at how we calculate the quartiles, and also later on we will do how to place those quartiles on a 5-number summary as part of the box plot. And then we'll take a 10 minutes break, we come back, we look at more exercises, more extra questions. Please remember the sessions are very interactive. If I am moving too fast and you're still not sure how we do things, stop me. We have 2 hours. stop me and I will explain again the concept, and I will show you again how to calculate certain things. Please do not wait until the end of the session and say, oh, but I'm still lost. We don't want to leave any student behind in this respect. So make sure that you ask a question. If I give you the assessment or activities to do, make sure that you do them on your own and have the answer. And then when we go back and do the feedback as a group, someone needs to volunteer and speak up, because then at least we will know that someone is able to do some sort of work. Or you can speak up and say, I don't know how to do certain things, and I want you to show me how to. And then we will go through it together, me and you. You cannot be quiet the whole session. So I hope you will be engaging me, and we will have a fruitful discussion and also fruitful feedback and work through the session together as a team. Okay, so by the end of the session, you should be able to find the quartile position and the quartile value. You should be able to calculate what an interquartile range will be. You should be able to identify the 5-number summary values and also construct a box plot. In the exam, I know it might be only one question in the exam, but that one question might have all of them. So you need to be able to know all of them in order for you to answer that one question. Remember, in the exam, one question weighs 4 marks for certain module, like 1510 and 1610. One question is 4 marks. So how do we even calculate the quartiles? So to start with this, first we need to calculate the quartile position. And then once we have the quartile position, we're going to calculate the quartile value. What is a quartile? A quartile is a split of ranked data. And that split, it means it will split the data into 4 blocks of 4 segments. And those segments, they will have equal values that makes up 100%, which means there will be the first part of the value will comprise of 25%, and the second one will comprise of 25%, which means anything below that will be almost 50% of the values will fall within that, and the third block will have 25%, and if we look at the below the values of that block will comprises of 75% of the data, and the last 25% will comprise, if we add all of them up, should always be equals to 1. It will be 100%. So it means with quartiles, what we do, we break the data into 4 segments, 4 groups. Sometimes it's not as easy as that to say these are the 4 distinct groups. So therefore, it means you have to use the formulas. But those 4 groups, they represent something. The first group represent, at the end of the first group, it will represent quartile 1, which accounts for 25% of the values. That will be below that quartile 1, and 75% of the values will be above that quartile 1. And there will also be a quartile 2, which is the middle value, which is the same as your median, which accounts for 50% of the values will be below that point, and 50% of the values will be up above that point. And the 75 quartile, or the third quartile, which accounts for 75% of the values that will be below, and 25% of the values will be above that point. We call that a quartile 3 value. In order for you to find the quartile 1, quartile 2, and quartile 3, you first need to locate the position. And locating the position, oh, sorry, I need to put this into a presentation mode. I'm so sorry, I left it as a view mode. Just give me a sec. Sorry about that. So finding the quartiles, we first need to locate the quartile position. And locating the quartile position and the quartile value, it means you need to order your data or sort your data from the smallest value to the highest value. So once you have sorted your data, then you are able to calculate the position of quartile or of any of the quartiles. To find the position of quartile 1, we use the formula Q1 is equals to n plus 1 divided by 4. Remember, there are 4 quarters, so we divide by 4, where our n is equivalent to our sample size or our sample value or our observations. And to get the quartile 2, we say n plus 1 divided by 2, which is almost similar to your median position. So, and to get to the quartile 3, we use 3 times n plus 1 divided by 4. So once we have calculated the position, sometimes there might be values that are not a whole number. So when you divide 16 by 4, you will get 16 divided by 4, you will get the answer as 4, which is a whole number. It makes it easy. So to find that quartile, you just count to position number 4, and that will give you your quartile value. But sometimes it's not as easy as that. So you will need to understand when you calculate 7.5 divided by 4, or 7 divided by 4 will not give you a whole number, but it will give you a decimal point. So you need to understand those rules on how to read those values or the position values in order for you to be able to go find the, quartile value. So you need to know how to get to read the position in order to find the quartile value. So some of the rules are as follows. If you calculate your quartile position and the results become a whole number, like 16 divided by 4 will give you 4. It's a whole number. Then you can use that position to go find your quartile value. Easy. You count 1, 2, 3, 4 because your data is sorted or it is in order from the lowest value to the highest value. If you calculate and you find that the results you get is in a fractional half, which means it's 0.5, 7.5, 1.5, 2.5, 3.5, 8.5, 16.5. If it's in a fractional half, then you need to take the average, like we did with the median. We take the average of the two values where the position is located. So if it's 7.5, you will go to position 7 and take position 8 value, add them together and divide by 2. That's what I mean by taking an average of the two values. If the result is not a fractional or is even not a whole number, then we need to round up or round down. For example, if we get the answer as 7.2, if we get the answer as, sorry about that, if we get the answer as 7.25, therefore it means the position will be at position number 7. We just round it up, we just round it down because the values are far away from position 8, but closer enough to position 7. If the value is 7.75, if the position is on 7.75, therefore we're going to round it up to 8 because the values are way too far from 7 but way too closer to 8. Therefore, we round it up. And those are the rules you're going to have to work with when you calculate the quartiles. So let's look at how we find quartiles. Finding the quartiles, we first need to get our data sorted. So let's say this is our data. And if we count this data, it's equivalent to 9. There are 9 records. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9. Our n is 9. Therefore, to calculate the first quartile, we use the formula Q1 is equals to n plus 1 divided by 4. Since we know that we're calculating quartile 1. So our n is 9 because our n is 9. We counted them. Plus 1 divided by 4, it gives us 2.5, which 2.5 will go to the value. It's located in position 1, 2.5. It's between 12 and 13. Since it is between 12 and 13, we're going to take the average of the two numbers and divide by 2. So 12 plus 13 divided by 2 gives us 12.5. Let's look at if we solve for all the quartiles, quartile 2 and quartile 3. So we know that we have 9 and we calculated quartile 1 and we found that it was in position 2.5 and the quartile value is 12.5 because 2.5 is located between two values, 12 and 13. We add both 12 and 13 and divide by 2. That gives us 12.5. Calculating quartile number 2. Remember, quartile 2 is like the median, is the same as the median. And we find it by using the position n plus 2, n plus 1 divided by 2. Our n is 9 plus 2 plus 1 is 10 divided by 2 gives us 5. It's on position 5th. So we go count 1, 2, 3, 4, 5. It's located on position 5. The value there is our median or is our quartile 2. It's equals to 60. Calculating quartile 3. Remember the formula is 3 times n plus 1 divided by 4. 3 times 10 is equals to 30 divided by 4. The answer gives us 7.5. Since it's 7.5, we count 1, 2, 3, 4, 5, 6, 7.5 lies between two values. It lies between 18 and 21. So it means we take 18 and 21, add them together, and we get the answer of 19.5. Quartile 1 and quartile 3 are not measures of central location, but quartile 2, because it's the same as your median, it is a measure of central tendency. Remember, measures of central tendency tells you the locality of your data or where your data is located. It's the same as measures of central location. So when we have quartile 1 and quartile 3, we can calculate what we call a interquartile range. An interquartile range just gives us the variation of your quartiles values. So what the quartile range does, interquartile range is the difference between your quartile 1 and your quartile 3. Remember, with measures of variation, we have what we call the range, and the range is equivalent to your highest value minus your lowest value. Since here we're working with quartiles, our highest quartile is quartile 3 and our lowest quartile is quartile 1. So our interquartile range will take the difference between quartile 1 and quartile 3. And it tells you the spread of your value in terms of your 50% of your data where it's located. An interquartile range it also covers the middle 50% of your data. So it will only cover that block. And you will see when we do the box plot where your quartile 1 and your quartile 3 are in terms of the box plot. And the interquartile range measures also the variability, and it's not influenced by the outliers because the outliers will be outside of your box plot. They might be captured or they might not exist. And I will show you when we draw an example of a box plot what I'm referring to. So now let's do an example of how we calculate this interquartile range. So remember, we have the data that we've calculated, that we used in the previous example, and we know that there were 9, and we've calculated what our quartile 1 is. We calculated what our quartile 3 is, not the position, but the value. So we calculated the quartile value for quartile 1 and the quartile value for quartile 3. To calculate the interquartile range, we use quartile 3 minus quartile 1. Quartile 3 was 19.5 and quartile 1 was 12.5. If we subtract one from the other, we get 7 as our interquartile range. With that, do you have any question? If there are no questions, I'm going to give you an exercise to do. Any question? Right, no questions. There is your exercise. Remember, quartile 1, you find the position, n plus 1, divide by 4. This is for quartile 1. For quartile 2, n plus 2, n plus 1, divide by 2. And for quartile 3, we use 3 times n plus 1, divide by 4. You have 10 minutes. When you are done, you can write on the chat your options. so that I can see how many of you are done. Okay, I see your answers. I see your answers. Let's see if they are right. Who wants to do this with me so that we can help those who don't know how to answer it? Anybody? Are you telling me all of you who answered and gave me an answer of 5? None of you wants to talk to me.
Hi, ma'am. I'll take a try.
Thank you very much. Let's do it. Question Q1.
It is 15. The Q1 is 15 plus 1 divided by 4. N plus 1 divided by 4 will give you 4.
So it's 16 divided by 4 gives us 4th position. Did you sort your data from lowest to highest? If I look at it, it's sorted already, unless if I am looking at Chinese written data here. Sorry about those who are Chinese. So the data is sorted, so we can count. Agree? So 4th position will give us 1, 2, 3, 4. 173 as our quartile 1. Quartile 2. I'm going to look at the options later on. First, I'm just going to do all the quartiles. Quartile 2, how did you calculate quartile 2?
It's N plus 1 divided by 2. So it will be 16 divided by 2 will give you the 8th position.
That will give us the 8th position.
Which is 201.
Which is 201. 1, 2, 3, 4, 5, 6, 7, 8. That will be that one there at the top. And quartile 3.
The question 3, the median is the same as Q2. So that will also be.
You are answering the questions. I was going to come back to the question later after I have answered, I've done all the quartiles. Okay.
Okay, quartile 3 is 3 times N plus 1 divided by 4. Which is 16 times 3 to give you 48 divided by 4. The answer is 12.
Okay. And the value will be on position 12. So I know that this is 8, 9, 10, 11, 12. That will be quartile 3. So if we look at option number 1, it asked for position. The position was 4. So therefore, this is correct. And we're looking for the incorrect answer. And number 2, it also asks for the position, and the position is 8. Therefore, this is the correct answer. And option number 3, it says the position of the median is 8. Do you agree? Yes, because the median position will be the same as quartile 2 position. So that will be correct. Position of quartile 3, it says it's on position 12, and we calculated that it is on position 12. The value of quartile 3, here it says it's 217, but we know that the value of quartile 3 is 216. So therefore, option 5 would have been the incorrect one. Any question?
Is this the type of questions that one will get in the exam, Ms. Boy?
Yes, you will get this kind of questions. Which module are you doing?
The 1-6.
Yes,
1610.
this will be the type of questions that you will get. Those who are doing 1501, this will probably be one of the multiple choice questions that you will answer, or it will be one of the written questions that you're going to answer. So if it's a written question, you will need to show your steps. The same way as I have shown the steps, you will also have to show the steps in that way. To say quartile 1 position is on position number this, and the quartile value is this. But those who are using, or those who are doing 1501, sometimes they, instead of using quartiles, they use percentile. They work almost exactly the same, but they will give you the formula of the percentile, because with percentile, you just calculate the percentage or the percentile. For example, with quartile 1, this is 25 percentile of the value. So it will give you a 25% of the distribution of your value. Sometimes those who are doing 1501, they will ask you what is what is the 90th percentile? It's the same thing. You just calculate the 90% value of all your values, and it will give you the position, and you can calculate and go find your 90th percentile value. Yes. Because if you look at this, 1 divided by 4, if you take 1 divided by 4, you will see that it is equivalent to 25%. So 25% times 9 times 15, it will give you 4. Let's do that. Let me get my calculator. So 0.25 times 15, the answer I get, it will be 3.75. And 3.75, I have to round it up. It will give me position number 4. So the logic will work the same. So instead of using the percentile where you multiply with the percentile, you can use the quartiles, the same values. Okay, let's move forward. Now let's look at, if we know what our quartile 1 is, and our quartile 2 is, and our quartile 3 is, then we can draw what we call a box plot. But a box plot is made up of 5 numbers. And that's what we're going to learn now. And with that, with the box plot, if you know those numbers, you can also, with the box plot, calculate what we call the interquartile range. And in interquartile range, in a sense, you will calculate it from the 5-number summary that also describe your center of your data. So there are so many things happening on the box plot. They tell you the center of your data. They also tell you the spread, how spread they are, and it also gives you the shape of your data in one go. So let's look at the 5-number summary, how it looks like. So this is what we call a box plot. And in a box plot, there will be 5 numbers that you need to remember. The minimum value, which will be your minimum value of your data point. Then it will give you your quartile 1 value, then gives you the quartile 2 value, quartile 3 value, and the maximum. So when you draw the box, the beginning of the box, this is the box, and this is also called a box whisker plot, because it's got whiskers. It's like a cat with the whiskers. So if you look, quartile 1 and quartile 3 makes up the edges of the box. In the middle of quartile 1 and quartile 3 is your quartile 2. The whiskers are made up of, the beginning of the whisker, it will be your minimum value, and at the end of the whisker will be your maximum value. If your data has outliers, let's say there is a value there which is very far away from the other value, it will be an outlier there. If this one has two values that are outliers, there will be somewhere there. Maybe these two values are 100 and some number. So very far from the rest of the other values. So those ones will be what we call the extreme liars or the outliers. So when we have the quartile 1 and quartile 3, so our quartile 1 and quartile 3 values, we can calculate the interquartile range. Remember our interquartile range, IQR, is given by your Q3 minus Q1. So we take, so this actually should be here, and this 71 should be there. So our quartile 3 is 57, and our quartile 1 is 30. So if we subtract one of those, it gives us the interquartile range. If in the exam they ask you to calculate the range, remember your range will be for this data set. Your range for the data set will be your highest value minus your lowest value. Your highest value here will be 70 minus 12. And therefore your range of your data will be equals to 70 minus 12, which is 58. And if you look at these two values, the interquartile range and the range, you can see that your range is bigger than your interquartile range. Any questions? So with the quartiles, you can also see the spread of your data. And in a word format, we can say, if we look at the interquartile, and we want to determine whether your data is skewed or is symmetric. If your quartile 1 value minus your smallest value, if it's bigger than your largest value minus the quartile 3 value. So what do we mean by that? What we mean, if this is your box and this is your quartile 3, and this is your quartile 1. So it says if the distance from this, from quartile 1 and the smallest, if this distance is bigger, so let's say this distance is 4. If I say quartile 1 minus the smallest value, I get 4. And the distance between quartile 3 and the highest value, and if I calculate this distance and I find that is 2, it says if this distance from quartile 1 and the smallest is bigger than this, it means your data is left skewed. So it means between the box and the whisker, this side, it will be taller than the other side. So it means the data, this side will tell me that it is big. In terms of the median, it also says when your quartile 1 difference from the mean is bigger than the quartile 3 from the mean. So in this instance, it looks at the box. So let me just draw the box here and draw your quartile 1 and quartile 3. It says if this is your median, so let's say your median, which is quartile 3, is there, and this is quartile 2 is there, and this is quartile 1. It says if my quartile, the distance between quartile 1 and the median, which is quartile 2, if this distance is bigger than this distance, then my data is left skewed. And that's what the 5-number summary tells you. If your quartile 2 is closer to quartile 3, your data is left skewed. For right skewed, same thing. It says if this is my box, the distance that side is bigger than the distance between the small and quartile 1 is bigger. So for quartile 3 minus or the highest value minus quartile 3. If it's bigger, then it means it is right skewed. The same way with the box, with the median. If this distance from Q1 and Q2 are close to one another, and they are Q2 and Q3 is bigger, then your data is right skewed. If the line is closer to Q1, it means your data is right skewed. For symmetrical values, therefore, it means everything is the same. So the distance between Q1 and small value and the distance between Q3 and largest value are exactly the same. So if we look at the difference here, if it's 2, this difference should also be equals to 2. If we look at the median, so it means if the box will be split into half, exactly 50-50%. And that's what you will have to recognize when it comes to the distribution of your data when we look at the quartiles. Any question? Any questions? If there are no questions, your exercise. I will check on the chat how many people have answered, and then we do the recap. You know that you don't have to type your own answer. You can just like the one that somebody already have typed, so that I can also see how many people have answered the same question. It makes it easier that way. There is a functionality if you tap on top of the answer that someone have answered, you will get a menu to like the answer. I think it can also give you, or it only gives you those emojis. You can use any of those emojis. Okay, so just to recap on what we did, let's draw the box plot. We know that a box plot is made up of the boxes Q1 and Q2 and Q3. And it has the whiskers, and the whiskers has the smallest value and the highest value. And from here, we can calculate the interquartile range. And Q1 is what we call the lowest quartile or the first quartile. It's called the lowest or the first quartile. And this is called the upper quartile value. And we know that this is the same as the median. That is, if we recap. The question was asking, the following measures can be obtained from a box plot, except if I look at everything that I just summarized, which one is not the measure of a box plot? And everybody agrees with number 3. Any questions? In the absence of a question, if you don't have, I'm going to give you an exercise. Please complete the exercise and also take a 5-minute break. And then we'll come back at 6:05. Make sure that you stand up from where you are seated and take a walk for 5 minutes or for 2 minutes and then come back. Stand away, go away from where you are and come back after 5 minutes. There is your exercise. Okay, welcome back. Have you answered the question? How are we doing? Have we tried to answer the question? I don't see any options. Am I unmute? Okay, only 3 people have answered the question. The rest, are you still working? Talk to me. Are you still busy? Buang Lim Natle, Brad Medbay, Tetang Nami, Kulumani Nami. Thank you, Nadine. Nadine is still busy. Remember, if you don't know how to do it, you must also ask.
Ma'am, can I ask a question while we wait?
Yes, you can.
The shape of distribution that we done under the measure of central tendency, is that the same as the relationship amongst the 5-number summary and distribution shape?
Not really. Remember, under the central tendency, we did the distribution of the data. We said it is symmetric when the mean and the median are the same.
Yes.
It is left skewed when the mean is bigger than the smaller than the median, and it's something like that. So since with the quartiles we don't have the mean, with the quartile we don't have the mean, but let's say, for example, if this question has a question where they ask you to calculate the mean, you can use the mean and the median to find the distribution. You don't have to necessarily go and use the quartiles.
Okay, thank you. I understand.
Yes. So let's see. Are you guys done now? Nadine, how far? Okay, mic not working, but are you done? Oh, done. Thank you. Yes. Okay. Okay, so let's answer this question. Who wants to to do with me? Nobody? Okay, so we need to sort the data first from lowest. Oh, thank you. Let's sort the data. You can read out the ones that you have.
I've got 3, 4, 6, 7, 9, 10, 14, and 23.
Thank you. Option number 1, median.
Yes, I started with a Q2 as n plus 1 divided by 2. So I took this 8 plus 1, which is 9 divided by 2 will give you 4.5.
4.5.
So if you count 4 places, it's between 7 and 9. So I added 7 plus 9 divided by 2 will give you 8.
So that is correct. The first quartile?
That's n plus 1 divided by 4. So we take again 8 plus 1, which is 9 divided by 4, will give you 2.25. We round it off to 2. And the second position will give you 14.
The first position will give you?
The 4 will give you 4.
Yes. And third quartile?
That is Q3 is 3 times n plus 1 divided by 4. So it's 3 times 9, which will give you 27 divided by 4. Answer is 6.75, and we round it off to 7. And the 7th position, the answer is 14.
So that is correct. The mean?
It is, you add all up and you divide it by 8. So it's 76 divided by 8, which will give you 9.5.
Why am I having 8, but you get 9.5? Oh, why am I counting? Yes, that's 9.5.
And then I said for the last one, the mean is more than the median. So it is right skewed.
Yes, so this is the incorrect one because it says the distribution is symmetric. But we know that the mean is greater than 8, which is our median. So it should be right skewed. More exercises. For the next hour, we will concentrate on the exercises. Your next exercise is that one in front of you. Right. You can download it as a PowerPoint presentation, then open it up and save as a PDF. It will come out nicely in a PDF document as well. Oh, sorry. That is if you have the PowerPoint slide in Visme as well. But if you created an infographic, make sure that it is a full page. Where are we? How far are we? Okay, I see 5 people. So it means you have the answer. Let's answer the question. The data is already sorted because it's 1, 2, 3, 4, 5, 6. So it's already in order. Quartile 1, Q1, n plus 1 divided by 4. There are 1, 2, 3, 4, 5, 6. So it's 6 plus 1 divided by 4, which is 7 divided by 4. It's 1.75. And that's what we have there. The value of Q2, so it means we first need to find the position. Q2 position, n plus 1 divided by 2. 7 divided by 2 is 3.5. 3.5 lies between the two values, 3 and 4. 3 plus 4 is 7 divided by 2 is 3.5. And that gives the value as 3. Question number 3 is the same as what I just did right now. So we know that the median is 3.5. And the value of the third quartile, Q3, is 3 times 7 divided by 2. Sorry, divide by 4, not 2. 3 times 7 is 21, divided by 4 gives us 5.25, which we can round it up to or round it down to 5, which is approximately position 5. And since it's in position 5, therefore it means 5 is the value. And the interquartile range, IQR, it's Q3 minus Q1. Our Q3 value is 5 minus our Q1 value. Our Q1 value, we get the position as 1.75. So it will be equals to the position 2, because this is 1.75. So minus 2, which is equals to 3. Therefore, that is correct. The only option that is not correct is option number 2. Your next exercise. Okay. Let's see. Are you still busy? Okay, all right, all right. What is the answer? Nothing. Oh, there we go, there we go. 4 is the correct answer. That's what you have. So we first have to sort our data. So let's do that. It's 44, 57, 85, 108, and 206. The median is 85 and it is equals to the mean. So it means they would have added all the values and divided by how many there are, 1, 2, 3, 4, 5. So they said for the mean is, the mean would have been 44 plus 57 plus 85 plus 108 plus 206 equals 500. So it would have been 500 divided by how many there are? There are only 5. 500 divided by 5 will give us 100. The median, we know the median is the same as quartile 2. So I'm just gonna do quartile 2, which is the median. Which is n plus 1 divided by 2. There are 5 plus 1 divided by 2, which is equals to 6 plus 6. 6 divided by 2 is equals to 3. If I count 1, 2, 3, it's 85. So the median is 85, which is equals to the mean. The mean is 100. So that one is incorrect. Quartile 1, n plus 1 divided by 2. 5 plus 1, not divide by 2, divide by 4. 5 plus 1 divided by 4, which is 6 divided by 4. 1.5. That's the position. 1.5 is between 44 plus 57 divided by 2. 44 plus 57 it's 101 divided by 2 is equals to 50.5. 50.5, therefore quartile 1 is incorrect. The median position, we calculated the median is on position number 3. It says the median is on position number 2. That is not correct. I'm gonna jump number 4 because I see that you all wrote number 4. The distribution is symmetric. When it's symmetric, it means the mean should be equals to the median. The mean is 100, the median is 85, so they are not equal. That cannot be. Otherwise, we can use our table, remember the shape says if quartile 1, the difference between quartile 1 and the smallest value, if they are bigger than the largest, to that they are left skewed. So, but if the distance is the same, they will be symmetric. So we can do the same. Our distance, Q1 minus the smallest value. Our Q1 value, we calculated it was 50.5. 50.5 minus our smallest value is 44. And the answer there will be 50.5 minus 44 is 6.5. 6.5. So now let's calculate the other one. Remember the other one is the highest value minus your Q3 value. Our highest value is 206 minus our Q3 value. We did find our Q3 value. We didn't go find our Q3 value. So we need to go calculate our Q3 value. Our Q3 is N1, or is 3 times 3 times N plus 1 divided by 4. So we know that is 3 times 5 plus 1 is 6, divide by 4, we get 6 times 3 equals 18 divided by 4. The answer is 4.5. So since it's 4.5, 1, 2, 3, 4.5 is between 108. So we'll take 108 plus 206 divide by 2. 108 plus 206 divide by 2 gives us 157. So our Q3 is 157. So now 206 minus 157 equals 49. And therefore, that is not the same as that, then it also means that is incorrect. But we just calculated Q3 and we found that it is 157. That is the only correct answer here. And that makes that the correct one. Calculate the interquartile range. We did find our Q3 was 157. And we find our Q1. Our Q1 is 50.5. Q1 is 50.5. The interquartile range is so they want to know what the interquartile range will be. So you know what the interquartile range formula is. Your IQR is Q3 minus Q1. And then you remember what the range is. The range is your highest value minus your lowest value. In order to answer that blank question, you need to know at least one of those two. You need to do something. Okay. I see. Anybody who has answered it? Okay. So have you calculated what your interquartile is? So our interquartile is 57 minus 50.5, which gives us 106.5. And if we look at all the values, we can see that it's not the same. So that cannot be any of those values. The first option, it says it is equals to the range. So what is the range? Your highest minus your lowest. Highest value in this instance is 206. Your lowest value is 44. So 206 minus 44 equals 162. Therefore, it cannot be the same as interquartile range. So those ones are not correct. So we know that. So then it leaves us with one. Number one says interquartile range is always less than the range. Why will that be correct? It's because, remember, your interquartile range, you calculate it here, IQR. That's where you calculate the interquartile range. And from the smallest value, that's where you calculate your range, from the smallest to your highest value. So yes, interquartile will always be smaller than your range. So that should be the correct answer. And I think we've done this. I'm going to skip that. And I'm going to skip this one and give you the last exercise. I think we did this. Yes, we did this one. So I'll leave it on this. Now, on this one, I don't expect you to go ahead and start calculating anything from here. But what I want to also highlight in the exam, you will find some questions that looks like that covers multiple things from the same information. So if you look at this question, it asks you to calculate the range, it asks you to calculate the interquartile range, it is asking you to calculate the coefficient of variation, it is asking you to calculate the range and then the interquartile range. It asks you to know whether interquartile range and the range are measures of variation, or the coefficient of variation is the measure of central tendency. You need to be very careful when you answer some of these questions like this, because they are very time consuming. For example, calculating a coefficient of variation, remember, it is your standard deviation divided by your mean. So it might take you longer to get the answer of 13.5. And I think last week or the past week, we did measures of central tendencies and measures of central location, where I showed you how to use your calculator. You need to go and learn those steps so that in the exam, just one question like this that weighs 4 marks can take you almost 30 minutes trying to answer the incorrect question or finding which one is incorrect, because they ask you to find the range and then they ask you to find the interquartile range. Remember also, finding the interquartile range, it means you need to calculate the quartile 1 and quartile 2 positions and also find their values. So you can see that it's very intensive and time consuming to do this. So when you go write the exam, make sure that you have prepared, or you prepare well, especially where you can minimize or maximize in terms of using your calculator, following the steps, making sure that you know how to use shortcuts to get to some of the questions as well. So for example, on this question, the first thing that you will do is start by eliminating the concept questions before you do the calculations. For example, the last 2 questions requires you not to do any calculation. By looking at those 2, if one of them is incorrect, then you will choose that as an option. And if both of them are correct and you need to move to the next one, you do it that way. So you take the ones with the least number of minutes. For example, the one that you can get a quick win with, and do that one and see and get it out of the way, and then concentrate on the one that is more complex at the later stage. So if I look at this, I already can see that they say coefficient of variation is a measure of central tendency. From there, I can see that it is the incorrect one, because I know that coefficient of variation, since we calculate it by using the measures of variation, it cannot be a measure of central tendency. And that would have been my incorrect answer. It's quick to answer the questions, but please don't go option by option by option by option, whereas you can do a process of elimination by looking at the easiest one out first. And with that, we're going to call it a quick 5 minutes early for today. So I'm going to recap on what we did. So today we looked at the interquartile range, and we looked at how to find the position of the value and the position and the value of the quartiles, whether it's quartile 1 or quartile 2 or quartile 3. Since you're writing online, make sure that you have all your formulas close by so that you know which formula to use. If you are going to write in a value-based, quartiles formulas are not given, so you will need to know how to find the quartile position. What are the values, the formulas you use to find those? Because in the exam, they will not give you those. But since you are writing online, all I can say is make sure that when you sit for your exams, you make sure that you have written all your formulas down. You can put them in order of the chapters so that you know when you answer your question paper. And usually your question papers follow, they're in a logical order of your chapters. So you will not go anyhow wrong when answering the questions, because if you have your formulas, you will know how to answer each one of them in that chronological order. Okay, so what we also did today, we also learned how to find the interquartile range, which we take from the value of the quartile 1 and the value of the quartile 2. The difference between, quartile 3, the difference between the two will give you the interquartile range. We also looked at the 5-number summary, which includes the highest number and the smallest number plus the quartiles. And we know with the quartiles that the median is the same as quartile 2. And you should by now know how the box plot works or looks like. And we also looked at how we get the shape of the distribution by looking at the quartiles as well. Remember, guys, if you need more assistance, especially with your assignments, I'm not talking about tomorrow is your assignment day. I know for 1610, you should be submitting your assignment 2 tomorrow. Please don't send me emails tomorrow because I will be busy. You need to do your assignment way ahead of time. Do not wait until before the day of submission to start looking at your assignment. But if you're struggling with any part of your module, whether it's 1501 or 1601 or 1610 or 1510, please do not hesitate to send us an email. Include your module code when you send the email and copy those 2 email addresses. One is mine, which is eboy@unisa.ac.za. The other one is the UNISA tutorial or numeracy center people. They need to be aware of all the activities that are happening with UNISA students, especially in the numeracy center space. So please, when you send an email, make sure that you copy them in and specify your module code, because I have so many students that I'm helping and they also need to know who the email is going to, because they also need to keep track of the activities that are happening around the employees or the contracts that they have issued to us as well. And when you send an email, please do not say, I don't understand statistics. Do not do that to me, because I will send you back and say, sorry, I cannot help you. Here are the links to the online session tutorials that you can watch. Please be specific. You cannot be telling me that you're struggling with the your entire statistics module. You should be saying, I am struggling with this question. This is how I approached it, and this is where I am stuck. And then I will help you. In that way, it's clearer, and it shows me that you are at least trying something as well on your side. With that, or on that note, I would like to say thank you for being part of the session today. Enjoy the rest of the evening. I will see you. Oh, that's the other thing I need to say. I forgot now. Next week, there will not be any session because it's a public holiday on the 24th. So the next session will be the following week in October. Enjoy your long weekend that is coming next. If you get a holiday on the Friday the 25th, enjoy, and I will see you in October. Please don't be strangers. I'm available on WhatsApp as well under your specific modules. Thank you so much. If there are no questions, I will post the feedback form on the chat. Please make sure that you complete that before you leave the session. Otherwise, thank you for coming through. Don't leave before I put it there. Okay, I have posted the feedback form. Please make sure that you complete that before you leave the session. Thank you guys for coming through.